Okay, this video is part 3 of a 3-part series on ionic nomenclature. This one's going to cover ionic compounds that include transition and post-transition metals that have multiple valencies. Basically, this means they can have more than one charge. First, you have to identify if it is a transition or post-transition metal. So I have boxed in the transition metals. Those are groups 3 through 12. The post-transition metals come underneath the metalloids. The two main ones out of the transition metals we'll be dealing with in this class are 10 and Pb, which is lead. Sn is 10, Pb is lead. What multiple valencies means is that, like copper, which is Cu, it can be a +1 or it could be a +2. We don't know which one it is. We have to see what's going on in the compound itself. Okay, but in the name, we have to identify whether it is the copper 1 ion or the copper 2 ion. And to do that, we include, number 2 says, include a Roman numeral behind the name of the metal to indicate the charge. Number 3, when you have the name and you need to come up with the, or you have the formula and you need to come up with the name, you can use the charge of the anion, the negative ion, that it is bonded to figure out the charge of the metal. And the exceptions to all of this are silver and zinc. Silver is always a +1, and that's Ag +1. And zinc is always +2. So those two do not need Roman numerals because they do not have multiple valencies. Those are the two that I want you to remember. All right, so let's try this out. The first 4 have the name and you have to come up with the formula. And the last 4 have the formula and you got to come up with the name. So for number 1, copper 2 sulfate. All right, copper is Cu. The Roman numeral 2 behind it is the charge, so it's got a +2 charge. Sulfate is a polyatomic ion. It's SO4, and it has a -2 charge. We use the charges +2 and -2 to figure out how many of each of the coppers and how many of the sulfates we're going to need for this formula. Since they cancel each other out, we only need one of each. So it's CuSO4. All right, copper 1 oxide. So Cu is copper. The Roman numeral 1 means that it's a +1 charge. And oxide is oxygen's ion. So oxygen is in group 16. Everything in group 16 gets a -2 charge. So looking at the +1 and the -2, the least common multiple is 2, so we're going to need 2 coppers and 1 oxygen to do an overall neutral charge for this compound. So our formula is Cu2O. 2 coppers and 1 oxygen. Okay, chromium cyanide. Chromium is Cr. The 3 behind it means that it's a +3 charge. And cyanide is a polyatomic ion, Cn, with a -1. So looking at those charges, we're going to need 3 cyanides to get that -3 to make a neutral compound. So Cr, and then Cn in parentheses with a 3 outside. Okay, if you don't put it in parentheses, it will be CrCN3, which is not 3 cyanides, it's just 3 nitrogens. So make sure you put those polyatomic ions in their parentheses. Okay, and then cobalt 2 hydroxide. Cobalt is Co. The Roman numeral 2 means it's +2. Hydroxide is a polyatomic ion, OH, with a -1. So looking at those charges, we're going to need 2 hydroxides and 1 cobalt. So CO, and then again, OH has to be in parentheses, 2. All right, doing the name from the formula. We're We're going to have to do a little drawing and visuals, most likely. We got to look and see what the cation is. Okay, the metal is iron. Iron on the periodic table is a transition metal. So iron's going to need a Roman numeral behind it. So we know the beginning is iron. And the anion is chlorine, which is chloride. Okay, but we got to figure out what goes in parentheses behind iron. To do that, looking at the formula, Fe, there is only one Fe, but there is two chlorides, or chlorine ions. So chlorine on the periodic table is in group 17, which we know anything in group 17 has a -1 charge. So each of those chlorines have a -1 charge for a total of -2. The iron has to cancel out the -2, so one iron would have to be +2. So you would put Roman numeral 2 in parentheses behind iron. Okay, the next one is Pb, that's lead. So lead. And Pb is right here. It is a post-transition metal, so we're going to have to put a Roman numeral behind it for its charge. And it's bonded to SO3, which is sulfite. That's a polyatomic ion. So in this formula, Pb, there's only one, and there's only one sulfite. And sulfite's charge is -2. So Pb, or lead's charge, has to be +2 to make a neutral compound. So you'll have Roman numeral 2 in parentheses behind lead's name. The next one is Co, which is cobalt. Okay, and cobalt is right next to iron. It is a transition metal. And there are two cobalts in this compound. Okay, and it's bonded to CO3, which is carbonate. Okay, we're going to need Roman numeral and then carbonate. All right, there are 3 carbonates. Okay, and carbonate has a -2 charge. So each one of these has a -2 charge. So the total negative charge is 6. So these 2 cobalts have to add up to +6. So each one would have a +3 charge. So the Roman numeral behind cobalt is 3. And the last one is Ag, which is silver, and nitrate. And you do not have to put a Roman numeral behind silver because silver is one of the 2 I told you. Silver and zinc don't have multiple valency. Silver is always +1, so you don't have to put a Roman numeral behind it.